Hello, my name is Ramon da Silva. I'm a PhD student at Pontifical Catholic University of Paraná, PUC-PR, in Brazil. So today I'm going to present the paper entitled Multi-Step Ahead Bitcoin Price Forecasting based on VMD and Symbol Learning Methods. The agenda of this presentation will be the introduction, the dataset description, the methodology used in this paper, the results, the conclusion, and then at the end, some considerations of the acknowledgements. So, a cryptocurrency is a digital asset designed to work as an exchange that uses strong cryptography to secure financial transactions. So, Bitcoin is considered the first decentralized cryptocurrency, and it was released in 2009. With the emergence of the cryptocurrency market, the Bitcoin has captured the global attention. So the Bitcoin price time series has a high volatility. So forecasting the Bitcoin price as accurate as possible becomes a challenge. Therefore, hybrid and symbol learning models can handle with this volatility. So VMD, variational mode decomposition, and stack and symbol learning approach were chosen to forecast Bitcoin prices 1 up to 3 days ahead. The objective of this paper is to develop a heterogeneous stack and symbol learning model for Bitcoin price forecasting multi-step ahead, which means 1, 2, and 3 days ahead. And the proposed model was composed by VMD and stack approaches, coupled with heterogeneous forecasting models. The dataset, the adopted dataset is composed by 2,045 daily observations from July 28th in 2010 until February 21st in 2016. The dataset was split into training and test sets, divided by 70 and 30% each. And the input systems, according to the table 1, is the opening price, the high price, the low price of the day, and the output system is the closing price, using a unit measure, the American dollars. The methodology of this paper is the dataset is decomposed, use VMD into 5 different components, the INF. Then each component is preprocessed using box-Cox transformation, and then each of these preprocessed data is trained by 4 different algorithms or models as base learning of the first layer of the stacking model. They are the K nearest neighbor, the support vector regression using linear kernel, the feed for the neural network, and the generalized linear model. So the base learning predictions we preprocess by correlation matrix, principal component analysis, and also box-Cox transformation. And at last, each of the preprocessed data are trained using Kubis regression in the meta-learning stacking level. So each of the model generated are evaluated using the performance measures. They are the relative root mean square errors, the symmetric mean absolute percentage errors, and the absolute percentage errors. And last, the statistical test named Diebold-Mariano test was used. So as you expected, the hybrid ensemble learning proposed approach outperformed the single models, the stack ensemble models, and the decomposed models in almost all forecasting horizons. Regarding the performance criteria, the models A and C are the most suitable to forecasting daily Bitcoin closing prices. Also, competitive results were obtained by key nearest neighbor forecasting 3 days ahead, as you can see the relative root mean square error. Also, in the left plot, we can see that the models A and model C presented the lower box plot. Also, the plot predictions show us that the models could learn the behavior and the pattern of the data for both training and test sets. The approach that combines VMD, stack ensemble approach, and Boxcox preprocessing was chosen for 1 day ahead forecasting, and VMD stacking and correlation matrix preprocessing was chosen to forecast 2 and 3 days ahead. In the Diebold-Mariano test results, the chosen models present lower statistical errors than compared models at level 1 up to 5% of significance. So the student proposed a novel heterogeneous decomposed ensemble learning model by using VMD and stack ensemble learning with different pre-processing algorithms to forecast Bitcoin price in multi-step ahead. The stack ensemble was composed by k-nearest neighbors, support vector regressions, feed-forward network neural network, and generalized linear model as base learners in the first layer, and using qubits as meta learners in the second layer. Indeed, the VMD stack approach had a better performance than compared model in almost all forecasting horizons. For future works, we suggest to adopt different combinations of models in both layers of the stack ensemble, also to optimize the hyperparameters of the models, to optimize the numbers of the components to be decomposed, use different decomposing methods, and also increasing the forecasting horizon interval to more than 3 days ahead. So the acknowledgement we would like to thanks the CAPES, CNPq, Fundação Araucária e PUC-PR for financial this work. And thank you so much for watching my presentation in this video. I wish you all the best. Goodbye.